Okay, allow me to do some explanation and teach you how to make use of your graphic calculator efficiently to get whatever answer that you need. Okay, now, okay, the first part, you want to find the value of K, you have to make full use of the information given. That is, you substitute your temperature as 20 equal to 5 plus 95 e to the power of negative K times 15. Okay, who listen here. If this question is given and they didn't say find the exact value of K, all right? They just said find K. So what I can do is, listen, after I substitute, all right? I can use my solver to help me to do. So what you need to do is you go to your solver. Do you know where to get your numerical solver? Yeah, you know where to get your numerical solver? Okay, you go to your numerical solver. Under E1, you type 20. Under E2, you type in 5 plus 95 e to the power of negative 15x. Hurry up. I'm trying to help those who don't know how to solve it numerically, algebraically. Okay, so there will be an x value come out, correct? Yeah, so try to put whatever value, don't be too big, don't be too small. Just maybe put 1, yeah, or 2, up to you. Then you press alpha, enter. Don't try to copy. Practice using your calculator first. Because I record down, you can view it again. Do you get the answer? After you put alpha, enter, what is the answer given? After you press your alpha, enter, what is the answer? Is it 0.408? No. Yes or no? Please let me know. No. You don't get 0.408. Okay, you try to put 0.2. See what is it? How is it go? Very funny. Huh? Yes? Do you get 0.408? Or 0.2 something. 2 something, sorry. I remember the wrong number. 2 something, correct? So you got your XS. So after you have written down that, your solver tell you, correct? So you can just say K equal to 0.2 to what? 1, 2, 3. Yes, 1, 2, 3. I forgot already. 1, 2, 3. 0.123. Are you clear? Hello? So you can use solver to do. So relax. So this is the, you don't have to tell the examiner this. You just write down this and you give me the answer, I give you full mark. But if the question says exact value of K, then you have no choice. So, but if they say exact value of K, right, you solve until here, right, you still will get 1 mark. Hello? Class, are you clear? Okay, now I'm going to teach you how to get the exact value of K. So I told you already, if you have your graphic calculator now, a lot of things you can be done. Okay, so I'm going to solve this. I will say 95. Okay, when I have e to the power of negative, can I put it as like that? I try not to have the negative Do you get me? So this is equal to 15. Am I right? Hello? So I have 15 e to the power of 15k is equal to 95. So e to the power of 15k is equal to 95 divided by 15. So this is equal to 19 over 3. So therefore 15k will be equal to ln 19 over 3. So k will be equal to ln 19 over 3 divided by 15. So this one, the approximate value is 0.123. Are you clear? So this will be how you solve it algebraically. Okay. Done. So now I know that my k is this value. So I will key into my GC. So now I know already, after I finish my part A, then I will go to my GC and key in my Y1 as, try not to key in this as your K, try to key in this as your K, so it's easier. The difference will be a little bit. Are you clear? Okay, so I will key in my Y1 as 5 plus 95 e to the power negative 0.123x. Are you clear? So I will key in at 0.123x. Okay, so this one I will key in so that afterward I can use it. Okay, now, so after I got my K, I key into my calculator, then I continue with my other part of the question. So what was the temperature of the liquid when it was first placed in the, so first place in means T equal to 0. So I look for T0. So I go to my graphic calculator, Y1, I call out, then I put X equal to 0. Okay, please practice. That is how you use your graphic calculator efficiently. So what is the answer? It will be 5 plus 95 e to the power 0. E to the power 0 is 1. So your graphic calculator should give you almost 100. Do you get that? Do you get that when you key in your Y10? Do you get 100? Yes or no? Yes. Okay, good. Okay, I'm done. So can I move on? So that is how you use your graphic calculator efficiently. Okay, let's move on to part C. Okay, listen here carefully. For part C, when I want to differentiate, correct, I will not replace my K with the value that I have found. So I will just write my T as 5 plus 95 e to the power negative KT. I will just write this and I differentiate from here. I don't want to replace my K with a value. So that is easier for me to differentiate. Okay, so now dt over d time. Okay, I cannot say T because the one is capital, D temperature over D time. Okay, so you differentiate 5, you get 0. So exponential, you copy down the whole thing. Time by K is a constant, correct? So that rate of change of negative KT will be negative K. So I will have negative K is a constant, time by 95 e to the power negative KT. But the question is, it you want us to show different thing, correct? So now, this thing and this thing, are they the same thing? Are they the same thing? So can I say that 95 e to the power negative kt is the same as t minus 5? So therefore, my dt over dt is equal to, I replace this with this. So I say negative k times t minus 5. So negative k is a constant, am I right? So it's the same as a constant times by t minus 5. So shown. That's it. Clear? Okay? So for part D, they want the rate of change. So I will call out my Y2 in my graphic calculator. So I will write down dt over dt. So for the first part, I call out Y2, then I put initial. Okay, so calculator will give you the answer you write down. Then for the second one, you call out Y2, you put in 10. For the third one, you call out Y2, you put in 20. That's it. You don't have to show me substitution or anything. Your answer may be a bit different from the back because we use the approximate value for K. We just key in 0.123 instead of the exact value. So it's fine. Are you clear? So you don't have to go and show the substitution into here. No need at all. Are you clear? You have your graphic calculator, so you can get all these answers from your graphic calculator easily. So that in the exam, you won't feel so taxing in calculation. Are you clear? So graphic calculator is very useful. You just relax and learn how to use a graphic calculator. So are y'all okay? You face the computer too much, really. Question 10, still remember? Yeah. That particular function, okay, this function is of this form. It's a product of a linear and an exponential term. Okay, so if you have a function like this, the shape of the curve, you know it will be this shape. We call this a search function. If you want to study the characteristic of this special function, we call it search function. You can go to YouTube, you just key in search function, they will come up with all sorts of application for you. Yeah. So this will be, so still remember how is the shape look like? Go up, local maximum, and come down, non-horizontal inflection point, then go like that. Am I right? So any function of this form, the shape of the graph will be like that. So, and there is a very special characteristic of the x-coordinate of the stationary point. You can get it from the function itself. That is 1 divided by b. So if I, okay, afterward okay, then at this point, that means I'm saying that fx is decreasing at the what? At the what? Fastest rate. Because at this part, the slope is the steepest. Am I right? And this is also called the inflection point. Non-stationary inflection point. Of y equal to fx. Am I right? So this is 2 over b. All go the same. So these are the special characteristic for this function. So if in the exam, so you should write this one down in your notes. And you even can find what is the x, y coordinate. If you want to, you go and find for yourself. So the y coordinate for this one will be a over be. Okay, that one you can search for yourself. So if in the exam I give you a function, for example I say hx, ht is equal to 5t e to the power negative 0.2t. Then I ask you, find the time when h is decreasing at the fastest rate. Do you know? This one, I give you 1 mark. You can just use this formula. 2 divided by 0.2, that is 10. You see? So that is the advantage of if you write this one down in your notes. You must understand your SAT2, you can bring in 1-page handwritten notes. So we try to get prepared as much as we can. So this is a special characteristic of a search function. But you have to recognize the function, it must go in this way. The form of the function must be of this form. Okay? Hello? Can or not? Okay, another form of function will be, general function will be logistic function that you can see in question 12, 3F. Okay, please go to question 12, 3F. 3F, question 12. Okay. Let me brief you on this first before so if the question give me a function, so what should I do? What is a good habit? Straight away key this BT into Y1. Because I got all the value. There's no unknown there, so I can straight away key in. So key in, then only start to do, please. Everyone key in, then only start to do. Okay, so you just call out your Y1, put in 0. So that give you 200, 2000 B's. Done, 1 mark. Okay, for this one, you write B1, take away B0, divided by B0 times 100. You just need to write this one down. Then key into your calculator like that. Go to your main screen. Y1, 1. Take away Y1, 0. Relax. Okay, then enter. Whatever answer you get from here, please, this is not your answer. 37.9%. I don't want to see any other number. Don't waste time writing out individual number. Clear? So relax. Y1, 1. Relax. You can even sing song if you want, silently. 37.8. Okay, 37.8. I don't know. I just how I heard what you all say, I just write down. Okay, 37.8%. Are you okay? So do I need to write down what is the value of B1? No need. You get me? So that is how you relax using your graphic calculator. Okay, let's go to part C. Is there a limit? So when you say, is there a limit? We have to go back to our BT function. So I will write down the BT function again because I don't want to explain from here. Okay, so as t approaches infinity, so we have to look at this first. Any terms involved t, we study one by one. Okay, so what happened? Please don't use rate in the exam. So what happened to e to the power negative 1.73t? Approaches? Every time e to the power of negative, you should think as, you should think this as what? 1 over e to the power 1.73t. Am I right? Got it? So 1 divided by very, very big number. What happened? Very, very small. Very, very small. What do you put? 0. So what happened to this whole thing? It will approach 1. Am I right? So therefore, this whole thing, that is your BT, will approach. If you don't want to write the formula, you can do so. Will approach what? 3,000. From above or from below? 3,000 divided by 1 is the biggest number, correct? The rest of this will be more than 1. So you divide, you will get less than 3,000. So this is the upper limit. So we write here from below. So question asked, is there a limit? Is there a limit? Yes. There is a limit. So if so, what is it? Are we going to say the limit is only 3,000? Or we are going to say it in a better way? Yes. The population of bees will not go beyond 3,000. Are you clear? Would that be okay? Okay, now Okay, to find, can I move on? Okay, to find B prime T. This one, because up there is a number, so I'm going to write BT as this, 3000, open bracket, 1 plus 0 0.5, e to the power negative 1.73t to the power negative 1. So I'm going to use chain rule to get the answer. So B prime T, 3000 multiplied by the power, copy down the whole thing, copy down the whole thing, power take away 1. I have no space, so I write down here, multiply by, you differentiate the power take away 1, negative 2, okay? Differentiate whatever inside the bracket. Exponential term, you copy down the whole thing. Copy down the whole thing. Time by, you differentiate the power. So finish your differentiation. So take out your graphic calculator, multiply all these numbers together, and tell me what is the answer. One, 1845. Thank you. At home more efficient, huh? Okay. So are you done? To explain why the population is increased over time. Okay, that means this is saying that the population always increasing. That means we are trying to prove that B prime T always greater than 0. So how we start? Look at here. How we start? We will start with like that. This is called all values of T. What happened to e to the power negative 1.73t? Exponential term. Are you all looking at the board and listen? Exponential term is always greater than 0. Am I right? The value for whatever t I put in. And the square value, can a square number be negative? No. So that is how you speak. So therefore, B prime T always greater than 0. So therefore, the rate is always positive, means the population is always increasing. Are you clear? That is how you prove. Okay. Shall we find the rate? Okay, for part E, you shouldn't have any problem. Why? You want to talk about? For part E, find the rate at which the population is increasing after 6 months. So you just say B prime 6. Do you need to substitute? No need. Use your calculator Y26. Please give me the answer. What's the answer? 0.0806. Okay. 0.0806 bees per month. Very slow, correct? Okay, F. Okay, F, you just sketch the graph. You go to the window, you set your T, X minimum as 0, and you go like that. Okay, if you just give me the graph like that, I give you 2 marks, right? You only get 1 mark. Do you know where is the 1 mark? Do you know where is the 1 mark that you miss out? If I give you 2 marks, you will miss out 1 mark. Who can tell me? I only will give you 1 mark if you give me the graph like that. Because from part C, you know something. You have to jot down whatever you found out in part C to put onto the graph. Can you tell me what is it? Yes, the horizontal asymptote. If you don't give me this for this type of graph, the horizontal asymptote, then I will deduct 1 mark from your graph. This function, there is no stationary point. Okay, this is called the logistic function. And for this one, the inflection point is not there. Okay, I will give you the general form of logistic function. Due to time factor, I will give you logistic function. Okay, logistic function, it will go in this way. This is your C. That is the limiting value. 1 plus A e to the power negative bt, bx. So logistic function, the function, it can go like that. S shape. There is an inflection point. Like for example, this case, the inflection point is negative. So it doesn't show on the graph. Okay, there is an inflection point. There is 2 horizontal asymptotes. Okay, one is the upper limit. The other one is the lower limit. That is 0. Right? And the y coordinate of the inflection point here, the value of the y is c over 2. So this is called a logistic function. If the inflection point is not half of the upper limit, we don't call it logistic. Are you clear? So that's all. Can or not? So this is called logistic function of this form. So straight away, if I ask you, is there an upper limit? If you jot this one down, you know already C is the upper limit, sure got. But if I ask you to show, you still have to go through the process step by step. But if I ask you the question, will the number of B go beyond 3,000? I ask you, your answer will be no, because 3,000 is the upper limit. So you can straight away give me the answer without working through. Are you clear? So the two important functions, I think you have to jot it down. If you want to know more about these two functions, can go to the YouTube and look for it. A lot of changes happen like that. If you want to know how is this graph look like, you do a zoom standard. You will see the shape. The shape will go like that, S shape. We call it the S shape. Okay? So please complete your exercise 3F. So tomorrow's second lesson, I will talk about optimization. Then I complete the whole chapter. Then the whole holiday will be yours to catch up the work.